I took altitude sickness medication and then slept and drank a lot of water.
Yeah.
I'll show you.
Must be hard.
Yeah. It was awesome.
Welcome.
Hello. How are
Come on
you?
in.
Good to see you.
Good to see you.
So this is Anna,
Hi,
Lucas,
nice
and
to meet you.
Papa.
Nice
Hi.
to meet you, Michael.
Anna.
Nice to meet you.
Michael, nice meeting you.
Nice to meet you guys. Come
So
on
he's one
in.
of the smartest guys I know. So I work with him.
I
And
wouldn't
he
say
has
that.
two jobs. He does art, so our whole bacteria thing.
You wouldn't say that,
And
but
does
he
all
just said
this-
it.
Wow.
He's
So
being too kind.
Yeah,
He's always
he's the guy to know.
great.
So Lucas, if you have
Planetarium.
questions,
This guy is your guy.
he's an expert. This is the planetarium.
Wow.
Planetarium. This is where we do shows and teach people about the stars and
Go look.
astronomy.
Yeah.
Yeah, you
Oh,
can come
really?
in.
Oh,
Wow.
this is amazing.
This is so cool.
Wow.
I do shows in here. In these chairs. Here, sit in one of these chairs.
Okay.
Sit down and then lean back.
Yeah, so
All right.
Oh, this is great. Can I take a nap right here?
Oh, he said no, go to the back.
Should we go to the back row? Back row.
Okay.
So I recommend sitting on the
Okay, let's go.
Front row.
What's that?
It's a platformer game from like the 2000s.
Oh, really? Is this from that game?
This is nice.
Is that cool?
Go ahead and have a seat.
Hey.
Mark, are you ready? Are you ready for the stars, Mark?
Yeah, Lucas likes astrophysics.
Well, astronomy more than astronomy.
Well, get excited. We're learn about the stars.
What is your major?
Computer science.
Computer science.
He just knows everything.
Planetarium and astronomy and planetary science.
You want to tell him about your job right now up at the observatory?
Sure. So, part-time I work at the observatory, which is south here about an hour, where we take pictures of the stars. And it's south of here an hour because the light pollution in Provo is actually kind of bad. So we go kind of into this remote place where we spend, anywhere from 1 to probably 5 nights there. And we see stuff like this. We're currently researching a star called XX Cygni, which is in it's in this part of the side. It's around here. And it's called the variable star. And variable stars are stars that grow in size and decrease in size by about 30% because of the way that the light pressure pushing out of the star is not in balance with the gravity that's pulling it in. So it increases and decreases in size. If our star was like that, you would actually be able to see the star change size over the course of like 3 hours.
Whoa.
Yeah.
Are there multiple variable stars, or is XX Cygni the only one we know
There's
of?
thousands.
Okay.
If not
So this is a
hundreds of
common
Did you
thing.
know this?
Yeah, but the really cool thing, especially they're called Cepheid variable stars. They are how we actually know distances across the. They're how we know distances across the universe.
Oh,
Because
wow.
variable stars, like this variable star, this isn't actually a variable star, but let's say that this is a variable star whose distance we know, right? And then we see another variable star in a galaxy super far away. We can look at the period of the increase and decrease in brightness, and it'll tell us, we create that relationship between the period luminosity relationship, and we can use that to determine how far away the galaxy is. And we do this for thousands and thousands of variable stars in the galaxy, and that'll give us an accurate definition and prediction of how far away the galaxy is.
That's cool.
So let me go ahead and let me pull up. Do you guys know where we're at in the sky?
Lucas might know. I don't.
Lucas, where are we at?
I see like a little bit of the Milky Way there. So
So yeah, we are on the surface of the Earth, but we're not in Provo, and we're not in Mexico. I'll give you those hints.
okay.
You asking where this picture is taken from?
Yeah, where is this picture taken
Oh,
from?
okay,
I think
okay.
it would be more eastern.
It's not on Earth though, he said.
It is on Earth.
Oh, it is on Earth? Oh,
It is
okay.
on Earth. Yeah.
Looks
Like-
eastern to me.
Like Eastern United States or?
No, like eastern.
Like Asia?
Sure, somewhere over there.
So it's not actually dependent on longitude. So it's not dependent on east or west. You'll be able to see the same stars here as you're also able to see at the same position,
Okay.
like
It's probably
longitudinally.
Is it farther south then?
It is not.
Oh, it's north.
So,
North?
you see this star? Do you guys know what this constellation is?
I have no idea.
This is the Big
Does it-
Dipper.
The one that looks like a kite.
Yeah, kind of looks like a kite or a little measuring cup.
Measuring cup. So we can take these two stars and we point these two stars to this star right here. Do you know what this star is?
Northern Star, right?
This is the northern star.
Oh, okay.
So if the northern star is directly above us, what does that tell us about our position on Earth?
Oh,
It's north.
yeah.
Yeah, we're on the
North Pole.
Good job.
North Pole.
Ah, that's interesting.
Is there an observatory?
On the North Pole?
Yeah.
No,
Okay.
we're currently standing on water.
Oh, nice.
Or ice, or you know.
So it's probably
whatever.
taken from a boat then?
No, so these are actually simulations.
Oh, okay.
So we're gonna go ahead and we're gonna go to our home. So we're gonna come back to Earth.
Oh.
So now we're back here in Provo. So you can see that the northern star's right here.
See. Uh-huh.
It's the North Star.
Yeah. This is the North Star. And you can tell
That's in Maui.
how high up on the Earth you are by taking the distance from the northern star to the horizon, and then you get the angle, and that'll tell you how far up or far down you are
Oh,
in
really?
the northern hemisphere.
I didn't know that.
So the closer the northern star is to the horizon,
Uh-huh.
the further south you are.
So is that what a sextant would do back in the day when they would navigate?
Exactly. You would measure
You'd
it,
measure the distance above the horizon,
and then you can actually tell your latitude and your longitude by measuring the time and then comparing your time to where the stars are.
Nice.
So you could use stellar navigation.
Yeah.
It's a little bit more complicated to find your longitude than it is your latitude,
Right.
but
That's so cool.
well, let's
Where's
go.
Orion's Belt?
Or you want to see Orion's Belt?
Yeah. Is that a wintertime constellation?
It is, yeah. So we won't be able to see it probably for another few months, but we'll go ahead and we'll fast forward in time.
You have a favorite constellation, Lucas? Or star?
Star, maybe UI Scooter.
Which one?
UI Scooter.
You know that star, Michael?
Which one?
UI what?
Scooter.
UI Scuti?
I've
Scuti?
never heard of that star.
You guys
The
cootie?
biggest star.
No, it's the
isn't it?
second biggest star.
Oh.
Second
It's the second biggest star.
You're talking about Eta Carina? Oh, VY Canis Majoris?
Is it that one?
No, I think that's the third largest one.
That's the third largest?
Or fourth, I'm not
Oh,
sure.
okay.
One of those.
There's also
So
UY,
is that the Milky Way?
That one. US.
UY Scooty.
That's one.
Yeah.
That's
that's
yeah. That's what he said.
Let me see. Alright, so we see coming up over the horizon,
There
we've
it
got
is.
Orion the Hunter right here.
That's my favorite constellation. I like
Orion.
Yeah.
Once I graduate BYU, I'm going to get a tattoo of Orion on my back.
But Orion is those three stars, or is it more than that?
Yeah, so you've got these three stars. This is his head up here.
Uh-huh.
His left shoulder, which is Betelgeuse, and then his right shoulder,
Oh, Betelgeuse.
which is Bellatrix. And you've got these three stars, which are the belt of Orion. And you've got his sword right here, which, do you see that right here? That doesn't look like a star. What do you think that is?
It looks like a
You see with the
dwarf
laser?
planet.
A galaxy.
It is actually the Orion Nebula.
A nebula, okay.
Yeah, so this is an active star forming region. It's what we call an O2 region, an O2 region. And if you look at this area through a telescope, you see a lot of really bright blue stars, but they're very young stars. They just formed in this area. All right.
So nebulae are forming stars then.
Yeah, so it's either forming stars or exploding stars.
Oh, okay.
There's also the Crab Nebula, which is right here.
Right.
So really young or really old?
Right here.
Yeah.
Or-
Either it's an exploded star or a place that a bunch of new stars are being formed.
Okay.
And you can actually see there's this kind of like feedback cycle where stars blowing up will push dust and actually activate star forming regions because the dust will kind of coalesce into a nebula because of the amount of energy that's been blown from the blowing up stars or the supernovae.
Like the phoenix.
So right here we've got Taurus the bull. So you've got his eye. This is the eye of the bull. These are his horns. And then you kind of go down. We've got the Pleiades right here, which is a star cluster. All of these stars right here formed in the same region. Let's see.
What is that big one? Like right, no, left? That one, yeah.
That's
The moon?
Oh, that's a moon? Oh.
Is it waxing or waning in that simulation?
So this is today.
Oh,
Really?
Wow.
Yep. So it's actually currently, I think, waning because we're
What's that in
approaching the new
Spanish?
moon.
I have no
You know
idea.
what that is? Waxing or waning?
Creciente or,
Yeah.
yeah. How do you say in Spanish?
Hold on to your feet.
Oh, I'm getting dizzy.
All right, so this is what the sky's gonna look like tonight. Can you guys tell me what this constellation is again?
Oh, the Big Dipper?
This is the Big Dipper. So,
To me, it
This-
looks like the Maui hook.
yeah, no, Maui Hook is actually right here.
Oh, really?
Oh yeah, look, you can see it.
Oh, there you
I
go.
can move it so it's closer in the sky.
I didn't realize that's a real constellation.
Yeah.
Yeah, me neither. It was like, just messing.
So, the actual official constellation, this is Scorpio.
Oh,
Scorpio.
okay.
Oh, this
You
is
can
okay.
see his pinchers are
Yeah.
like right here.
Yeah.
And then these are his eyes,
Uh-huh.
the three eyes of the scorpion. And you've got kind of his body, and then you've got his tail right here.
Wow,
This
nice.
constellation in Hawaiian mythology
This is Maui's hook.
is Maui's hook.
Oh, cool.
Oh, I didn't know it was a real thing.
Yeah.
You're welcome.
So the third brightest star in the night sky is this one right here. This is called Arcturus. The best way that you can find Arcturus, and if you look in the night sky tonight, if it's not cloudy, is you can take the Big Dipper, go on its handle, and then you arc Arcturus. So that's kind of the
Arcturus.
yeah.
Arcturus is
Yeah.
a star, right?
So Arcturus is a star, and you arc the Arcturus.
And it's, if I remember right, is it hotter or cooler than the sun? Because it's more red, right?
It's more red, but it's actually a lot bigger than the sun.
Okay.
So in that case, it would be cooler
Yeah.
because color is a direct indication of temperature.
Right. Okay. Size indicates more.
Well, size indicates where it's at in its life cycle.
I see.
So if the star is very, very big and also very, very cool, that means it's towards the end of its life cycle.
Oh, interesting.
If the star is very, very hot but pretty small,
It's like a new
it's
star.
probably like at the very end of its life cycle. It's a white dwarf. White dwarfs are about the size of the Earth. And I can show you guys some nebula that we've actually taken pictures of at the observatory. The ones I'm showing you right now aren't the ones that we've taken at the observatory, but let's see, June the star. So we're gonna look at the Ring Nebula. So the Ring Nebula is right here. It is a planetary nebula. As you can see, you've got this kind of small, tiny dot, and that's the white dwarf. And then when the sun, and this is going to be the eventual fate of our sun. So the sun, after it finishes burning all of the hydrogen inside of its core, it's going to blow up, right? And it's not going to explode, but it's going to blow up in terms of size. So it's going to become almost as big as like either Earth's orbit or Mars's orbit,
Okay.
somewhere in between.
Okay.
And what will happen is at that point, the sun will be, well, instead of burning hydrogen, it'll start burning helium. And once it runs out of burning helium, the light pressure is going to just basically have it shed all of its energy, and it's just going to kind of poof off its the outer layers of its atmosphere. So I'll go ahead and I'll play it again.
That's cool.
Hey, Lucas has a theory of how to avoid the sun from exploding.
Oh, how?
He says that,
Let Lucas explain.
well, tell him.
Well, I have no idea how you would do it, but if you can drain the hydrogen, then you can prolong the star's lifespan.
And the heavy metals, right? That's what you said?
Well, if it's a heavy metal star, but if it's a star that can produce iron, then yeah. But if it's like a star like our sun that can't produce iron, then it would just be the hydrogen.
Right. So then we actually do see that in a lot of like binaries. So what happens, and this is what we call a type 1 supernovae, where you'll have you also see them, they're called blue stragglers. They're stars. Blue stars tend to have shorter life cycles, right? A blue star tends to live about 500 million years. Our sun will live about 10 billion years, and then red dwarfs live about 1 trillion years. So it's about an order of magnitude in between each size. And there's like an entire spectrum, but the general trend is as the star gets larger, the shorter its lifespan, because it goes through and burns through its fuel a lot faster.
You said the smaller ones burn out quicker, right?
Or
which ones last 1 trillion years?
The red dwarfs. So the smaller ones last longer.
Oh, okay. Okay,
Yeah.
gotcha.
Because they're not burning through their hydrogen as fast.
Okay.
And the reason why is we see that red stars are convection stars, so they don't actually have a core, but they're burning through all of their hydrogen. Whereas
blue dwarfs are convection, or not in convection, they have a core.
they have a core. So like a blue star is going to compress all of its hydrogen, and it's going to start, because of like how massive the blue stars are,
Yeah.
before it's able to burn up all of its hydrogen, it's already going to be fusing iron at its core.
Wow.
And iron is what we call stellar dust. So, or like cosmic ash. So you cannot fuse iron together to make another element and still have produce energy.
Yeah.
So that's where fusion like basically cuts out, where it doesn't
Right.
work anymore.
Okay.
But to kind of go back to your theory, if you end up taking hydrogen off of the star, it decreases in size or decreases in mass, and thus is able to actually live longer. So if we were able to take off the helium, then and that would be very difficult. Like you would need something that's of similar gravitational influence. So like usually you have a white dwarf that has a companion with another star, and then you'll see that it's kind of like a zombie. It's stealing fusion, or it's stealing hydrogen from the star. That kind of makes sense. So it's sucking the hydrogen off, and then it's decreasing the mass of the other star. What?
You said zombie star?
Yeah, they're called zombie stars. Yeah. But if we're specifically talking about white dwarfs, when it's sucking this energy off of the star, then it ends up exploding, because we have this thing called the Pauli exclusion principle, where the white dwarfs are so dense that if you add any more energy to them, then the protons and neutrons end up occupying the same space, and they don't have enough pressure to fuse into neutrons, which would then turn it into a neutron star, so it just explodes. And that's what we call a type 1 supernovae, type 1A supernovae. Which is also another distance indicator, because type 1A supernova tend to be pretty consistent in terms of brightness, varying on distance. So if we see a type 1 supernova, we're able to classify it and measure its brightness, then we can tell how far away it is.
That's really cool. You can use the luminosity to
Yeah.
figure out distances between stars.
Right. So we've been talking a lot about stars, but do you guys want to move on to galaxies?
Let's see.
Yeah.
So let's go ahead and let's take a look at some galaxies. So we were talking previously about supernovae. Last summer we did a research project on this galaxy right here. This galaxy is called the Pinwheel Galaxy.
Yeah, I've seen that.
It's what we call a grand spiral, because you can see these majestic spiral arms. And there's this area right here. So I want you to look at this picture and like really soak it in, but specifically this area of the picture, right? The next picture that I want to show you is going to be a little bit different. So we're going to see the supernovae.
What program do you use for
It's called CCD Autopilot.
CC?
To take the data and then to process the data. So this is the supernovae. Well, it will be, I think.
Is that the same?
Yeah, this
Oh, there
is,
it goes.
Yeah.
Okay.
So this is the galaxy, and you take a look right here that this bright spot didn't appear, or it wasn't on the previous image. So this bright spot got super bright in May of last year, and then it decreased in brightness over the course of the next 3 or 4 months. And because of that, we were able to measure the brightness decrease. Because it decreased over 3 months, we were able to tell that was a star dying, or a type 2 supernovae. So that's when a blue giant at the very end of its life exploded and basically, went supernovae. And that's similar to what Betelgeuse is going to do in maybe the next 30 to 300 years. We think it's going to explode.
So if you observed that a few months ago, what were your calculations of when it actually happened? How long ago it exploded?
It's just whatever the distance to the galaxy is.
Okay, so whatever.
How far away is the Pinwheel?
Hundreds
Light years.
of thousands of light years. A lot.
So a long time ago.
A long time ago. But to us, I mean, it pretty much happened last year, right?
Right.
Wow, it is amazing to witness, like,
Yeah.
in a few months that it wasn't there and now it's there. Wow.
So the next
Is that a small
galaxy that we're going to look at is the Whirlpool Galaxy.
Whirlpool?
Yeah.
Okay.
So the Whirlpool Galaxy is just right beneath the Big Dipper. And it's kind of an interesting galaxy because we actually see that these are a pair of colliding galaxies. This galaxy right here, and then the spiral galaxy right here, and they're colliding together, and you can see that the spiral galaxy is so gravitationally dominant that it's sucking all of the material from the other mini galaxies. So it's like a whirlpool sucking in a ship.
So eventually it's not going to be there?
Maybe. It just depends on.
Yeah, what happens when two galaxies collide?
Like Andromeda and the Milky Way?
Yeah.
Something like that.
Who's gonna win?
Yeah.
What?
Who's gonna win, Andromeda or the Milky Way? Who's gonna suck?
Andromeda, 100%. Andromeda is about 2 or 3 times larger.
Oh,
than the
okay.
Milky Way. Yeah.
It's like a fight.
It's like a fight, yeah.
UFC.
But they end up actually sharing the
And
same.
now,
So this is another spiral galaxy. This is the M81,
wow.
Oh, cool.
and you can see I think it's a pretty galaxy. But we've been looking a lot at spiral galaxies, but there's other types of galaxies too. This is called the Cigar Galaxy. And the Cigar Galaxy has a bunch of young stars in the middle, but then you can also see there's a lot of really interesting dust right there too.
When you take these pictures, are they like what sort of exposure are you doing? Like how long does it take to capture
So
one of those?
for the pretty pictures, they take about 5 minutes.
Oh,
But then we take pictures of those and stack them together.
oh, and you do some like subtomogram averaging, kind of the
Pretty
equivalent of
much.
that for astronomy.
Yeah. You basically you take all of the pictures and you average them together, and then it increases the signal to noise ratio.
Right.
So yeah, essentially subtomogram average.
Yep.
So yes, we were talking about Scorpio. This is also a really interesting area of the sky, particularly because we've got this constellation right here. What does this look like to you guys?
I've got no imagination at all.
You guys see a teapot?
I was about to say a teapot.
Yeah, so you've got the spout right here, you've got the hat or the top, handle, and it looks like it's pouring into the Milky Way, right? So if we take this star and this star, and we go that same distance to this area right here, this is where the center of the Milky Way is. And this is where the black hole at the center of the Milky Way that's actively feeding
Oh,
thousands of
interesting.
stars.
Okay.
That's where it is right there.
Right there.
I like Sagittarius a lot. It's got a lot of really interesting objects on it. It's also my star sign. So.
That was mine too. Yeah.
Oh, you're
What-
born
what-
in
yeah.
December or November?
November.
November.
You? December.
December, yeah.
We're all Sagittarius.
We're the best people, actually.
We are the best people.
No.
Scientifically proven.
I did some research and.
Yeah.
Brag about it.
Yeah.
All right. Well,
Oh, thank you.
I'm done with kind of my presentation, but I'll go ahead and I'll give you guys, or I'll put on a show for you guys to also watch.
All right.
If you guys have enough time, like if you don't.
Sure. You have the coolest job,
Are
man.
you dying from hunger, Pato? Or?
No, I'm
Okay.
I'm
I wanna
fine.
make sure you're okay.
Yeah, this is fine.
Okay. We'll go get some food after this. Oh, look at that.
Wow.
Thanks, Michael. That was so awesome.
Wow.
On the surface of our world and high above, huge mechanical eyes and ears provide our generation with an amazing view of the heavens, almost as though we could see through the eyes of God. They allow us to peer deep into space and paradoxically back billions of years into time. To view the development of the universe at its earliest moments, and to marvel at its wonders today. Once upon a time, there was no time, or anything else. Then, in an amazing incident about 12 billion years ago, what had been without form and void became a dazzling universe of energized radiation and light. How or why this happened is one of the greatest mysteries of all. Perhaps a mystery so profound as to be unsolvable by science alone. No human instruments have revealed what happened during the first 300,000 years of existence. We do know it was a universe of energy, not matter. As this fireball cooled, what had been without form and void became a maelstrom of hydrogen and helium, creating its own space and time as it grew ever larger. This marks the point in time and space where our human instruments start revealing what's happening. The nuclear, gravitational, and magnetic forces are sculpting the gases into clouds. Squeezing the clouds to form stars. Pulling the stars together to form clumps. Clumping the stars into great spherical collections of ancient suns. the ancient factories which manufacture the materials later to become our world and ourselves.